So today we looked at cosine law and probably asking yourself, didn't I just learn sine law? Why do I need to learn another law? And the problem is that even though sine law is really helpful for solving all kinds of triangles, there's one kind of triangle it cannot solve. Now remember, sine law we had to use on triangles that do not have a right angle. Okay, so uh, cosine law is the same, but we're going to use it for a very special kind. So sine law was helpful when we knew two angles or when we knew two sides and an angle, as long as that angle was opposite one of the sides. But what if the angle is not opposite one of the known sides, like this triangle below? Okay, if you look at this, we tried to let's label this triangle A, B, C. If we tried to use sine law here, we would come up with something like this. So let's say we have A over sine A, we would have an unknown, A over sine 80, equals, and then let's choose, we could do C or B. We do have two sides, let's do B. So B is 6 over sine of, and we don't actually know the angle for B. So the problem here is that we have two unknowns. We don't know what A is, we don't know what sine B is. And that's a problem. So sine law would actually not solve this triangle for us. Oops, I erased the question there. So sine is not going to be any good for this particular triangle. So that's when we use the tool of cosine law. And cosine law looks a little more complicated when you look first than sine law. But once you get the hang of it, it's really not much harder. So if you look down here, um, let's say this is triangle ABC. So all the points are A, B, and C. And then of course you name the side opposite that angle with the same letter, just so you can remember. So all you need to remember is for the angle you're looking for. So let's say this is 50 degrees. You're looking for angle A. You want to use one of these three versions of cosine law. You're going to look for the one that starts with A and ends with A. Okay, so because you're looking for, say you have angle A and you're looking for information on side A, then you're going to look for the cosine law that starts with A and ends with A. If, let's say, you had angle B, you would be looking at B, the one that starts with B and ends with B. Okay, so that's kind of what you're looking for, is which does the equation begin with and end with the letter that I'm working with. And you're going to see in a little bit what I'm talking about. Oops. Okay, so cosine law, there's three different ways of writing it. The simplest way is just to look at this one. Uh, if we change to looking for side, we just flip the letters around, and you can see here we've just taken the B at the beginning and the end, and then we've got A and C in the middle. And I'm going to show you some examples on how to do that. Now, I've shown you examples before in your notes on how to solve using cosine law. Let's actually look in your notes at the last example that we never actually got to solve. This is kind of a fun one because in this case, remember we said, how do we know when to use cosine law? And I said, we know to use cosine law when we see an angle that looks cozy, right? Because cosine starts with kind of the same letters as cozy. So this angle 80 degrees looks like it's kind of cozy in between those two sides. So we know two sides and we know the angle between them. So that angle is cozy. So we can use cosine law. Now, the only other time we use cosine law is actually when we don't know any angles. Okay? We don't know any angles here. So how do we do cosine law? Well, if I said solve for angle B, I could say solve for angle A or C, actually, any of them. But I'm going to say solve for angle B. Now, if it's asking for something to do with B, I'm going to put together a cosine equation that has B at the beginning and B at the end. So I'm going to start with B, squared equals, and I'm going to end way over here with cos of angle B. So it starts with B, it ends with B. And everything in the middle here is A and C stuff. So I'm going to go A squared plus C squared minus 2AC times cos B. We'll put a bracket there just because there's two C's next to each other. Now you'll notice right away here that we're solving for B squared, but we actually already have side B. What we really want to solve for is angle B. So we want to try to get cos B all by itself. So it's going to take a little bit of algebra to get that to happen. So let's try to get the a squared and the c squared over here on its own. So we're going to go b squared minus a squared minus c squared, because that's what we're doing to get rid of it over here, right? Equals negative 2ac times cos b. And we still have to get this cos b by itself, right? So we got to get rid of this negative 2ac. So let's divide everything by negative 2ac. Okay, what we end up with is all of this equals cos b. Okay, because remember we're solving for angle b, so we want to have this b by itself. So to get it really by itself, we can do the inverse cos. Okay, so let's rewrite this so we can see what we're doing. So b squared minus a squared minus c squared equals negative 2ac equals cos of b. So to get b by itself, we have to do cos to the negative. So just to make this easy, we're going to switch this equation around. b equals inverse cos, or cos to the negative 1, times all of this. b squared minus a squared minus c squared, over negative 2ac. It's really complicated, but really all we've done here is we've taken our cosine equation and we've just isolated a different variable. We've flipped it around so that we're solving for angle b instead of side b. That's all we've done. And if we're careful with our algebra, then we shouldn't come across any problems doing this. So let's take a look at the goal for a second. We haven't written down our known values yet. Okay, so we know that the side opposite b is going to be called b. So b side equals 15, a equals 18, side c equals 10, and those are our knowns, our known values. Okay, so let's plug some of those numbers in. I'll go back to blue. Well, let's stay in red here. So angle b, let's put an angle there so we know we're looking at angles, is the cosine of negative 1 of b squared 15 squared minus a is 18, so 18 squared minus b squared. All of that over negative 2 times AC, so 18 times 10. Again, this looks really complicated, but if we're really neat and tidy with our algebra, it should come out all right. So let's punch this into our calculator. Again, said this before, but my calculator looks different than yours. That's okay. So let's do 15 squared minus 18 squared minus, we know 10 squared is 100, so let's just do minus 100. So minus 199, or negative 199, over negative 2 times 18 times 10. If you punch that into the calculator, you're going to get negative 360. So if you do inverse cos of that number, so let's try that. We know that negative 199 divided by negative 360 equals 0.5527777, and so on, okay? So if we do inverse cos of that, what you're going to get is 56.44 and so on degrees, okay? So let's solve the nearest degree. So if I go back, we can round this to 56 degrees. Now, if that seems complicated or hard, I encourage you to go back and pause this video where you get confused and rewind it and rewatch it every time you get confused. This is the second type of triangle that you can use cosine law for. Either you're going to have a cozy angle, like this one, where we've got 46 degrees cozy between 12 and 13, or you're going to have a triangle like this where you don't even know any angles, but you're able to actually solve your angles. Now, we've solved for angle B, which we now know is 56 degrees. And if we wanted to solve for angle A or angle C, we could use cosine law again, or we could even use sine law this time. That would be up to you. So if it said solve the triangle, you'd actually be using both and sine law. So that's it.